At one time or another, we've all experienced it. The urban driver's nightmare, with all its impacts. Personal frustration, costly delays, tensions. Fuel wasted as motors idle and air pollution mounts. Buses held up, passengers losing time. Bicycle riders endangered. Trucks waiting, cargoes delayed, drivers falling behind schedule. More chances of accidents as cars, trucks, buses, taxis, bicycles, and pedestrians compete for the right-of-way at intersections. There are real tangible costs when traffic signal systems don't work at their best. When they do work at their best, the traffic signal is an impartial referee, setting the rules, helping all roadway users take turns in negotiating the intersection safely and with a minimum of delay. And when traffic signals are well coordinated, the result can be a smoother, more continuous flow for all roadway users, greater safety, more efficient use of fuel, and less pollution. Keep in mind that the traffic lights you see at the intersection are only the tip of the iceberg. The bulk of an effective traffic signal system lies behind the scenes, where professional traffic engineers do their jobs. This film aims to provide an understanding of the traffic signal systems they design and operate. At the heart of everything is signal timing. One of the key elements of signal timing is the signal cycle, which is the complete sequence of signal indications, changing from green to yellow to red and back to green again. Within the cycle, each signal indication of green and yellow allocating the right-of-way is known as a phase. The more phases, the more delay, and of course, there is only so much time that can be provided. A signal timing plan sets the duration of the various phases and of total cycle. A cycle may be as short as 40 seconds, or as much as 120 seconds or more. And the timing plan fixes the duration of the phases within the cycle. Here, more time is allocated to the green for the main street traffic, with less time for movement of traffic on the cross street. When timing is set on a pre-scheduled basis, the duration of the signal displays in each cycle is fixed. It is the same limited amount of time for each cycle and its phases, regardless of the traffic demand. Intersection timing may also be on a traffic-actuated basis that adapts the length of green displays in response to varying traffic demands. Here, a wire loop detector embedded in the approach to the intersection is activated by vehicles passing over it, sending electrical impulses to the roadside detector electronics and triggering action by the controller to change the traffic signal to green. This method automatically adjusts the green time to the traffic demand at a given moment. Activating the signal displays is the job of the controller equipment. For a pre-timed controller, this may be the older electromechanical type, or especially for traffic-actuated control, it may be solid-state electronic type equipment. Signal controller manufacturers now provide microprocessor-based controllers to achieve intersection control at less cost and with less maintenance. It's a relatively simple matter to develop a timing plan for an individual intersection, and even for a series of intersections if the traffic on an arterial is in one direction. For progressive traffic flow, the signals are programmed to establish a definite timing relationship between adjacent signals. This relationship is termed an offset. It's a much more complex problem when there's a two-way flow. Perfect progression in both directions can seldom be achieved. It's far more complicated still to time for progressive traffic flow in a network of intersections. Further complicating the problem, Different timing plans are needed for different times of the day, during rush hours, for example, with their peak traffic flow. And these timing plans will need to be revised frequently because of changing traffic patterns caused by construction and development projects, the redesign of old streets, and the building of new ones. Fortunately, modern computer technology is helping traffic engineers develop timing plans and keep them up to date. Several computer programs are available to aid in timing plan development. One of them, Transit 7F, was developed to optimize signal timing and has been implemented in many jurisdictions throughout the United States through the Federal Highway Administration's National Signal Timing Optimization Project, known as NSTOP. California's program, for example, conducted in 41 cities, showed these results for the first year of testing. Vehicle stops and delays were reduced by more than 14%. Fuel use declined by 6%. Speed or travel time improved by an average of 6.5%. The estimated total annual cost benefit was $31,900,000. Since the project cost was only $2 million, the benefit to cost ratio turned out to be a very substantial 16 to 1. Just imagine the scale of benefits if traffic signal systems were optimized in all urban areas across the nation. Timing plans and computer software are the brains of the traffic signal system. The brawn is in the hardware, the equipment and machines, the cables and wires that carry out the instructions. In a number of cities, especially in downtown areas, the older type electromechanical-based systems may be found. The master controller acts as a 7-day clock, sending out electrical impulses that activate a limited number of timing plans by time of day and day of week. The actual timing plans are set at the intersection, where a technician adjusts the timing dials. But just as in so many other kinds of municipal activity that are now computerized, today's cities are moving toward computerized signal systems in order to do a more effective job of managing street transportation. In computerized signal systems, detectors at intersections register current traffic information and feed it back almost instantaneously to a control center. Here, the information is quickly analyzed by the computer, and appropriate new timing instructions are transmitted to the field in rapid response to changing traffic demands. The control center is the command post for the computerized traffic signal system, the point where timely information about system performance comes in, where operators are alerted to signal failures and other problems, where steps for remedial action are taken, and where new timing instructions are cranked into the system in response to changing conditions. An almost infinite number of timing plans can be set from the control center to accommodate the major changes in daily traffic patterns, such as the morning peak hours, the evening peak hours, and so on. Typically, about 8 timing plans will be set in a computerized system, and special timing plans can be called up almost instantly in emergencies that affect traffic, a fire, a serious accident, or a broken water main. Computerized systems are very cost-effective. For example, one study has shown that for each dollar spent on computerized signal system improvements, 9 vehicle hours of travel time can be saved. In addition, about an 18% improvement in travel time can be expected when a computer-controlled system replaces an interconnected pre-timed system. From software to hardware, a traffic signal system is only a structure, a tool. It takes on life only through the activities and dedication of the staff people in using that tool. The staff applies professional expertise to the development of timing plans and patterns to meet changing needs. And both engineers and technicians keep a sharp eye on the operations of the system, monitoring performance, ready to act when something goes wrong. Often enough, something does go wrong. In one major city without a computerized system, it was estimated that at any given moment, there were problems at fully half the intersections. Malfunctions at intersections show up immediately in a computerized system. The operator can quickly confirm and diagnose the problem and take corrective action. For example, the problem might be a defective controller unit. In cases like this, the technician may repair it on the spot, or he may take the faulty equipment back to the maintenance shop. How much staff and budget are needed to operate and maintain a traffic signal system? That varies widely, depending on a city's size, its geography, and the frequency with which timing plans are updated. What counts critically is that regardless of city size, the traffic engineering budget must be fully adequate for the job at hand. Large enough for the signal system to be operated effectively with modern equipment. One thing the professionals know, nothing stands still in the world of traffic signals. From the earliest days of traffic control, there has always been a push for more knowledge, more effective and responsive equipment and systems. That's why pioneers in the profession keep upgrading traffic signal systems. And that's why the Federal Highway Administration sponsors research studies and makes the resulting information, software systems, and training courses available to states, cities, and counties for their use. For use is what all the effort is about, helping communities put advanced equipment into operation, update and optimize timing plans, modernize master control centers. As this happens, step by step, our cities will approach the urban driver's dream of the ideal traffic signal system.
Like clockwork.
Smooth sailing.
Great.
Beautiful.
How's that for timing?